Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be taking a look at how to write equations of lines parallel and perpendicular to a given line through a specified point. So instructions are as follows. Write equations of the lines parallel and perpendicular to the given line through the given point. So for question number 1, let's say we have the line y equals 1/2 x plus 3. And we're to write equation of the line parallel and perpendicular to this line through the point 2, 3. All right, so we're going to start with the parallel line first. So equation of a parallel line. All right, so we're going to start by writing down the equation of the original line that we're given. So the original line that's given is y equals 1/2 x plus 3. So in order to write the equation of a line, the two ingredients that we need are the slope and a point, okay, because we're going to be using the point slope formula. So we just need a slope, m, and a point, x1, y1. That's sufficient to write down the equation of a line, all right? Okay, so to write the equation of a line parallel to this, we need the slope. We're going to call that slope m parallel, all right? So in order to find the slope of the other line, we need to know the slope of this line that's given here. So the formula that will help us find the slope of the given line is y equals mx plus b, the slope-intercept form of the equation of a line. The coefficient of x is your slope. So we can see here that m, the original slope, is 1/2. Now we want the slope of the parallel line. Let's call it m parallel, okay? If two lines are parallel, their slopes are the same. So basically, m is equal to m parallel. That's what you got to keep in mind. If two lines are parallel, their slopes are the same. So m and m parallel are exactly the same, all right? So the slope of some parallel line to this line is called m parallel, is going to be exactly the same thing as this, which is 1/2. All right, so that's one ingredient that we need, the slope. We also need a point. The point that we are going to use is a given point, which is 2, 3. So the slope of a parallel line is 1/2, and the point is 2, 3. Okay, so that basically tells us that x1 is 2, the x coordinate, and y1 is 3. Now, these are the ingredients. We need the recipe to pull it together. So the recipe is the formula, the point slope form of the equation of a line. So that's given by y minus y1 equals m times x minus x1. All right, y minus y1 equals m times x minus x1. This is known as the point slope form of the equation of a line. All right, so we have the point and the slope, so we're just going to plug them in here. In this particular case, we're going to be using m parallel, so we're writing the equation of a parallel line. So we're going to have y minus y1. What is y1? y1 is 3. Y minus 3 is equal to m parallel, which is 1/2. Right, times x minus x1. x1 is 2. So all we're substituting in are just y1, m, and x1. So this right here gives us the answer in the first form. This answer is known as the point slope form of the equation of the line. All right, PSF. So this is the point slope form. And then we're also going to write the slope-intercept form. Okay, so this is a point slope form. So to get the slope-intercept form, we're just going to simplify this, get y by itself, and then we'll be done. All right, so let's do it. So to get the slope-intercept form, let's rewrite the equation. We have y minus 3 is equal to 1/2 x minus 2. To get y by itself, let's distribute this 1/2 first across these two terms to the right. And then we have y minus 3 is equal to 1/2 x minus 1/2 times 2. Okay, so we have y minus 3 is equal to 1/2 x. Half of 2 is just 1, because this one goes here 1, 2 goes here 1, so it's just 1. And then lastly, you just add 3 to both sides, plus 3, plus 3. And then we have our final answer. So our final answer, y, is equal to 1/2 x plus 2. All right, so this is the slope of this is the equation of a parallel line in slope-intercept form. Slope-intercept form. Okay, so that's that for the perpendicular. Now let's do the parallel. I mean, this is for parallel. Now let's do perpendicular. Very similar procedure, but it's just only one little difference. All right, perpendicular line. So for the perpendicular line, we have the slope y equals mx plus b. All right, and then the original line that we had is y equals 1/2 x plus 3. So based on this form, we know that the slope m is going to be 1/2. Okay, but in this case, we need m perpendicular. All right, so what's the relationship between a line and a perpendicular line? If two lines are perpendicular, the slope of one is the negative reciprocal of the other. All right, so m perpendicular here, m perpendicular is going to be negative 1 over m. Negative reciprocal, okay? So m perpendicular is going to be, what you do here is you just flip the number and flip the sign. Okay, so this is positive 1/2, so you're going to flip it to negative, and 1/2 you flip it over to 2 over 1. Negative reciprocal simplifies to negative 2. All right, using the same point, 2, 3, which tells us that x1 is 2 and y1 is 3. All right, so following the same procedures, we're going to plug in these ingredients into the point slope form of the equation of a line. Y minus y1 equals m x minus x1. When we carry, so this one we're going to be using m perpendicular, all right, since we're dealing with perpendicular. So if we substitute, we're going to have y minus y1 is 3, is equal to m perpendicular, which is negative 2, the negative reciprocal of 1/2, times x minus x1, which is 2. Okay, so this, ladies and gentlemen, is the equation of a line perpendicular to the original line and going through the point 2, 3. All right, so this is a point slope form, and then we can do the slope intercept form next. So point slope form. So the slope intercept form, we're just going to get y by itself. Okay, so let's do that. We have y minus 3 is equal to negative 2 times x minus 2. All right, and then just distribute negative 2 across these two terms right here. Bam, bam. And then that gives us y minus 3 is equal to negative 2x plus 4, like that. So don't forget, negative 2 times negative 2 is positive 4. To get y by itself, we're simply going to add 3 to both sides of the equation. And then that gives us our solution. Y is equal to negative 2x plus 7. That's the equation of the line perpendicular to the given line in slope-intercept form. So this is in slope-intercept form. All right, so what we're going to do now is we're going to check our work by graphing all 3 lines on the same coordinate system so we can see the connection between parallel and perpendicular lines to a given point, okay? So let's start by generating our coordinate system. So we have a coordinate system, that's the y coordinate, and that's the x coordinate right there. Let's see if it's good enough. Looks good. All right, so we have 3 lines that we're going to be graphing. Let's start with the original line. All right, so let's call it YO. Y original is equal to 1/2 x plus 3. So with this line, we know that the slope m is 1/2. So you're going to rise 1 and run 2, rise over run. And then your slope intercept b is equal to 3. So you're going to start at the point 0, 3. Okay? Just use y equals mx plus b to get these. All right, so let's graph the first line. Y equals 1/2 x plus 3. So we start with 3. 1, 2, 3. Starting with 3. We go up 1 over 2 over 2. Like that, rise 1, run 2. All right, so let's draw the first line. Let's do the first one in blue. Y original, let's make it blue. So this is what we have right here. So this is the first line. Okay. All right, and we have 2 more other lines to go. Bam, bam. Okay, and then the second line is the y parallel. So y parallel is the first answer we got, 1/2 x plus 2. All right, so with this information, another thing to keep in mind is everything has to go through the point 2, 3. So let's graph that point 2, 3. So the parallel and perpendicular line have to go through 2, 3. So 1, 2, 1, 2, 3. So this point right here is a point that the other 2 lines have to go through, point 2, 3. All right, so make sure. All right, so the other one that we have for this y parallel, m is equal to 1/2, m parallel, right? And then b is 2 for this case. So we're going to be starting at the point 0, 2. Okay, so let's graph that one in red. So starting from the point 2, we're going to rise 1 and run 2. Perfect, we hit that point. See that? Rise 1 and run 2. Now this is what a parallel line looks like. Let's draw this one in red. A parallel line is a line that is on the same plane with the original line but never intersects. Okay? 2 lines on the same plane that never intersect are parallel lines. That's what we have right here. Okay, 2 parallel lines. And then this one goes over the target point, which is 2, 3. All right. Now let's go ahead and draw the second one, the last one, which is a perpendicular line. All right, so the perpendicular line, y perpendicular was, let's see, y equals negative 2x plus 7. Okay, so in this particular case, remember what we found the slope. So the slope of the perpendicular line to the original was -2, and then your y-intercept is 7. So basically, so b is, what is it, 7. So we're basically going to be starting from 0, 7, okay? So b is 7, so we're going to be starting at 0, 7. So let's graph that. So 0, 7, 0. This one we're going to make it green, okay? So starting from 7, 1, 2, 3, 4, 5, 6, 7. So that point there is 7. Okay, so we're going to go, the slope is -2 over 1, which means we're going to fall 2 and run 1. Fall 2, run 1. Okay? This is original. The m parallel here, we have to rise 1 and run 2 like we did with the original. Okay, so let's do it. So we're going to fall 2, 1, 2, and run 1. Fall 2, 1, 2, and run 1. Bam! Goes through the same point, 2, 3, our target point, which is what we want. All right, so there goes the graph of, we're going to draw the graph of m perpendicular right now. So that's what it looks like right there. So you see how it intersects at 90 degrees, right? That's what perpendicular lines mean. If two lines intersect at 90 degrees to each other, then they're perpendicular to each other. Okay, so let's go ahead and write down the significance of what we have sketched here so far. This is a perpendicular line. Y perpendicular is negative 2x plus 7. As you can see, it intersects the original line at 90 degrees, and it goes through that point, 2, 3. So this is the target point right here. Everything has to go through this point 2, 3, the two lines that we drew, okay? And then this is y parallel. Y parallel is 1/2 x plus 2, and this is the original line, y sub 0, the original line that we started from. Y sub 0 is equal to 1/2 x plus 3. All right, so from geometry, if you've already taken it, remember that if two lines are parallel, you just use that notation right there. That means that they have the same slope and they're parallel. All right, so there you have it. Thanks so much for taking the time to watch this presentation. We really appreciate it. Don't forget to help support our channel with your likes, comments, and subscriptions. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching, and we'll see you another time. Goodbye.